Okay, so the next unit is differential equations. And so a differential equation is an equation involving the derivative actually it might be the derivatives of an unknown equation. And I'm going to ask you to look in the option book to see Unit M for examples in science, and we're going to be studying. So we will study first order differential equations. And this is going to be in the form of f of x comma y dy dx plus g of xy equals to 0. So what is this notation? Well, the idea is there's some y. There's some y, right? And it's like a function of x. That's the idea. And so this is the derivative of that function, right? This is the derivative. Okay, and this f of xy and this g of xy is just another function with the x's and y's in some weird like combination. So an example might be, 7x squared y minus 2, dy dx minus x squared over y equals 7. This is a differential equation. There's some function. There's a function. Its derivative times some combination of xy minus some combination of xy is equal to 7. Now, we're not going to study something as difficult as this. But if you think about it, we've already solved differential equations. Because I've said to you the derivative of the function is equal to x squared, and then I also gave you a condition. I said that f of 3 equals 8, and we solved this. How did we solve this? Well, we said just take the integral of both sides. So we know that the integral of dy dx is y, and that's 1/3 x cubed plus the c. Always remember the c goes on the right. The condition was 8 equals 8. F of 3 equals 8. So we know 8 equals 1/3 3 squared, 3 cubed plus c, and that this was 8 equals 27 divided by 3 is 9. C equals -1. So the final function was y equals 1/3 x cubed minus 1. And that was what we did. So we did solve a differential equation. Once again, we had an equation that connected the derivative of a function and the combination of x's and y's. Now, let's take a look at the first thing we're going to do. The first type we're going to solve, just in this lesson, is we're going to be able to separate the x and the y. So the first lesson, this lesson is called separable differential equations. Separable differential equations. And we're going to do it a little different than what we did there. The idea is we're going to, in this form, we're able to easily separate the dx and the dy and match it up with an f function and a y function. So it's in the form dy over dx equals f of x divided by g of y. Once again, there's just a function of x and a function of y. So let's start with something simple. How about a dy over dx equals x? Okay. So I say, you know what? I want the dy's on the left, and I want the dx's on the right. So I multiply both sides by dx, and I have dy equals x dx. Now, next step, how do I undo the differential? Take the integral of both sides, okay? And I have y is equal to x squared over 2 plus c. The problem is going to give you a boundary condition, and you'll find the c. Once again, keep put the c on the left. Well, let's get interesting. Dy over dx equals y. Here's your first real college level differential equation. Here we're saying a function is equal to its derivative. Well, we know it's e to the x because we know that because we just studied that. Let's see how this works out. Once again, I want the y's and the dy's on the left, the x's and the dx's on the right. Well, if I multiply both sides by dx, I have dy equals y dx. I don't want that y there. How do I undo multiplication? Divide both sides by y. So I have dy over y equals dx. How do I undo a derivative? Take the integral of both sides. Well, what's the integral of 1 over y? ln of y. What's the integral of dx? Well, there's a secret 1 there, so this is x plus c. Okay. Watch. Well, we know from our years of studying, I want y alone. So what I'm going to do is I'm going to raise both sides, make this exponent to the e, right? So I now have y is equal to e to the x times e to the c, using the exponent rules. But you know what? I'm going to make this e to c simply c e to the x. And hence, we just proved that the derivative y equals c e to the x, and the derivative is equal to each other. And so you technically just solved your first differential equation. Let's move on. Now, these get complicated, and they like using the art. They like nice. Let's try another one. They like arc. They like, this is a way that they can get you to use those weird, arctangent rules. Okay, next example. 2x dy dx minus 1 equals y squared. Well, I want my differential alone with something, and I want a term on the right. So you know what? Any suggestions? Yeah, let's get rid of that one. 2x dy over dx equals y squared plus 1. Nice. Now I have an expression, a function solely based on x, and I have a function solely based on y. Whenever you see y squared plus 1, x squared plus 1, you know, and we're going to be taking the integral arctangent. Well, I need to get them on the right side, so let me move the dx over to the right. So I have the dy is fine on the right. If the dy is in the denominator on the left, I'm going to put it in the numerator on the left. On the right, I'm sorry. The dy is in the denominator here. It's going to go in the numerator on the right side. Let me get the 2x over here, and let me get the y squared over here. Basic multiplication. Well, and the idea is keep the y's on the left. Well, let's take the integral of both sides. Okay. We know from the formula book, and you kind of, I don't want to tell you to memorize, you kind of should know this. Once again, you know it's the arctangent of y squared plus 1 is equal to 1/2 ln of absolute value of x plus c. Now here's where it gets tedious. Okay? So fine, let's solve for y. So if the arctan of an angle is the value, no, the arctan of the value is the angle, then the value is the tangent of the angle. Sorry. The arctan of the ratio is equal to the angle. That means the tangent of the angle is equal to the ratio. But once you're just undoing arctan, oh, sorry. Sorry. It's the arctan of y. And this simply, so y equals the tangent of 1/2 lx plus e. I apologize for that. Now, let's add in a boundary condition. So let's add a boundary condition. Because I want you to see I want you to see how this plays out, how we figure out the c. I'm going to tell you that y of 1 equals 1, right? Y of 1 is 1. That's the boundary, because I want to find that c. So, let's see. 1 is equal to the tangent, open parentheses, ln of 1/2 ln of 1 plus c, okay? 1 equals the tangent of, the ln of 1 is 0, this goes out, tangent of c, therefore c is pi over 4. Final answer, the final answer, y equals, can you see me down there? Nice. Y equals the tangent, open parentheses, 1/2 ln of x plus pi over 4. Don't get freaked out by this. It's just, go through the flow. Remember that the integral of 1 over y squared plus 1 is the arctan of y. The integral of 1 over x is ln of x. Follow through, solve for y, and then look for the boundary condition. Okay, let's try another one. Ready? Are you ready for the challenge? The next one is dy over dx is equal to x, open parentheses, 1 plus y over e to the x. Well, let's think about this. Well, once again, you're looking at this, you know you can separate it. You can keep the x's together and the y's together. So I know that this is dy. I want to get rid of that 1 plus y, stick it in the denominator. I'm going to have x e to the x dx. This is an opportunity for them to do integration by parts. You should know how to do that. Let's do that quickly. U equals x, dv equals e to the x, du equals 1, v equals e to the x. Therefore, because I apologize, I skipped a step. We know we want to take the integral of both sides. This is the ln of 1 plus y. This is equal to, this is u e to the x minus the integral of e to the x. So it's x e to the x minus e to the x plus c. Right, remember that plus c is there. Did I give you a boundary condition? No, I did not. And we have, let's see what we have here. Well, how do I undo an ln? Both of these become exponents. So we have 1 plus y. 1 plus y is equal to e to the x minus e to the x, right, plus c. Okay, and what I'm going to do first is, I'm going to change this to c in front, because e to the c, it's just a constant. E to the x minus e to the x, and then that plus 1 minus 1. Once again, like we did over there, we just this is just a constant. It's just a number, so we're going to put it in front here. Now, the next thing I want to talk about is some of the word problems. Just simply when you hear the phrase, the rate of growth is proportional to its current size. Like P, let's call it P. So when a question is structured like that, once again, you have a differential equation because we're seeing a couple of let's talk about this. Let's go through this question. Now, so the first thing I see is rate of growth is proportional to current size P. So I know the variable is P, okay? And yeah, so how do we write the rate of growth? Well, that's dP over dt is equal to, well, it's not equal to P, it's proportional to P. And so this is the type of question with that structuring. Now, I looked over all the IB questions, all the option questions of differential equations. They give you the equations, so you don't have to worry about putting the equations together. They're giving you the equation. So what I want to do, well, then you just look at is Newton's cooling. Newton's law of cooling. And Newton's law of cooling, it says the rate a temperature is changing is proportional to the difference between temperature T, I guess the current temperature, and the temperature of some environment. We'll call that T naught. Can you see me over there? Yeah. And so the idea, once again, I don't want to belabor this. I mean, we'll go over some problems, but I just want you to see these science laws, the wording actually can be made into a math problem. So once again, Newton's law of cooling is the rate of temperature is changing is proportional to the difference between the current temperature of the object, and the temperature of some environment, which is kind of cool. And let's make that into an equation. So we have dt, the rate over time the temperature is changing is proportional to the difference of the current temperature minus the environment. And so let me read a problem out of the book. It's out of the book. Can you take a snapshot? Can you see that? Good. So the problem is, police discover a dead body at 6 in the morning in a room maintained at 22 degrees Celsius. When discovered, the body's temperature was 30 degrees Celsius. 3 hours later, the body's temperature had dropped to 26 degrees Celsius. The body temperature at the time of death is assumed to be negative 37 degrees. Estimate the time at which the death occurred. Now, let me make a little adjustment here, because we're going to make this negative K. Why negative K? Because the temperature is dropping. It's decreasing because it cools down. Obviously, it cools to the room temperature. That's the idea of cooling. So let's get some information of this. So at time 6, that's T equals 6, what do we know? We know the temperature was 30 degrees. What's some other information we have? We know that 3 hours later, the temperature dropped to 26 degrees, okay? And the body temperature at the time of death is assumed to be 37 degrees. So estimate the time when the death occurred. Well, also, once again, what's the T0? Well, the room is 22 degrees Celsius. Okay, so let's think about this. Well, I have a differential equation, right? And that's dt over dt is equal to negative k at minus 22. Okay, well, let's solve this first. Let's solve this first. I'm sorry. So let's solve this. So we have dt over t minus 22 is equal to negative k dt. Please remember, temperature versus time. This k is just a number. It's like the number 3. This is no different than like dy over dx. We're dealing with y's and x's. Anything else is just variables. In this case, we're dealing with t's, big T's, and little t's. The k is just a variable. Over here, if we're dealing with p and t, that's the p. It's p's and t's. Everything else is just variables. Fine. So we were able to separate them off, take the integral of both sides. We have ln of absolute value of t minus 22 is equal to negative kt plus c. Once again, that's just like the number 5, okay? How do we undo the ln? Well, we have t minus 22 is equal to e to the negative kt plus c, and then we're going to end up substituting t equals c e to the negative kt plus 22. So, what do we have here? Well, we have our equation, right? We have our equation, and that's going to be we're going to be able to tell what the temperature of the body when they found it, right? But we first need to find this k and the c. Well, 2 equations, 2 unknowns. It all comes back to these basic algebraic tricks. Let's continue. Let's go on. Did I give you 2 pieces of information? Did you get 2 pieces of information? Yeah. Let's get the first equation. T is 6. Little t is 6. After 6 hours, yeah. After 6 hours or 6 a.m., the temperature was 30. So we have 30 is equal to c e to the negative 6k. And what's another piece of information we have? Oh, well, at the 9th hour, the temperature was 26 degrees. 26 equals c e to the negative 9k. Okay? Oh, plus 22. Plus 22. So let's clean this up a little bit. 8 is equal to c e to the negative 6k, and 4 is equal to c e to the negative 9k. Any suggestions how I can get rid of that c? Well, just divide them. Let's see, 8 divided by 4 is equal to c e to the negative 6k over c e to the negative 9k, which equals e to the 3k. So we have e 3 to the k equals 2, and that means that we have 3k equals ln of 2, therefore k equals ln of 2 over 3. Okay. Well, now we have to find the c. So how do we find? So this is find the k. This is find the c. Okay, let's find c. Well, this is nice because this ln term is going to the exponent, so it's going to nicely go away. So let's take the first one. We have 8 is equal to c e to the 6 ln of 2 over 3. These problems work out nicely. Don't freak out. Just be like, follow through. Once I think I'm like when we get back, and because I might ask you this specific question, just specifically so I see you go through the tedium, the small tiny steps. Well, this is what? This is c e to the what? This is negative 2, right? ln of 2. Well, what is that? 8 equals c 1/4, right? Because the 2 comes up here, so it becomes so e to the ln of 2 to the negative 2. This is 1/4, and then c equals 32, and therefore we have our equation. We have our k, and we have our c. Okay, so I'm redoing the video because the ending was really bad. So the equation is 37 equals 32 e to the negative ln of 2 over 3 t plus 22. This was the equation. So, sorry, let me get a new pen. Sorry. So the idea is, what does this equation represent? This represents the cooling. So this is the equation we're looking for. We're told that the body, when we found it, was 37 degrees, and we want to know when we found it. But let me take the 37 out for a second, and let me put a big T here. What's going on here? Well, the way I look at this, at the initial time at midnight, we can see here, because 0 times negative ln 2 over 3 is 0, e to the 0 is 1. At midnight, the temperature was 54 degrees. That was the temperature, I guess Fahrenheit, because, it's an American book. Or maybe, who knows? Anyway, it's 54 degrees at midnight. Now, the thing is, so the question is, how long until it was 37 degrees? So 37 equals 32 e to the negative ln of 2 over 3 t plus 22. You could do this by hand. So what do we have? We have 37 minus 22 is 15. So we have 15 over 32 is equal to e to the negative ln of 2, 3t. If we take the ln of both sides, we have ln of 15 over 32 equals negative ln of 2 over 3t, and therefore the time is ln of 15 over 32 times negative 3 over ln of 2. Now, obviously, this is a calculator problem. You can see that from the start. So what you could have done was put this in the GDC for NSolver and solve for t. What you would get is t equals negative. Yeah. I'm sorry. No. Because of the negative here, t equals 3.28. Okay. So then they want to know exactly what time it is. So you know that this is like 3 a.m. Right? So the answer is 3:17 a.m. How do we get that? Well, let's think about it for a second. The three is easy. That's the 3 hours. The question is, what's the 28? So you say, okay, 28 over 100 is equal to some time over 60. That's the idea of the minutes. And then you get your calculator. Hey Siri, 28 times 60 divided by 100.
28 times 60 divided by 100 is 16.8.
16.8, that's the minutes. Hence, therefore, at 3:17 a.m., this is when they believe this is when the detectives believe they found that when the body was dead. This is when the person died.